Don't forget to subscribe and press the bell icon to never miss a video from testbook.com.
हेलो एवरीवन, गुड इवनिंग एवरीवन, हाउ आर यू ऑल? कैसे हैं आप सब? गुड इवनिंग एवरीवन, हेलो, गुड इवनिंग एवरीवन, कैसे हैं आप सब? गुड इवनिंग एवरीवन, गुड इवनिंग एवरीवन, कैसे हैं आप सब? गुड इवनिंग एवरीवन, गुड इवनिंग, हाउ आर यू ऑल? हाउ आर यू ऑल? कैसे हो आप सब? ओके, सो डियर स्टूडेंट्स, सो लास्ट क्लास में हमने क्या डिस्कस किया? पिछली क्लास में हम ऑलरेडी डिस्कस कर चुके हैं, हाईवे मटेरियल्स को हम स्टार्ट कर चुके थे पिछली क्लास में, राइट? अब हम क्या करेंगे, इस पर्टिकुलर टॉपिक को जिसका नाम है हाईवे मटेरियल्स को हम आगे प्रोसीड करेंगे, राइट? इसमें और भी बहुत सारे टेस्ट होते हैं, दैट इज व्हाट वी आर गोइंग टू स्टडी इन टुडेज क्लास. So if you have not watched the previous lectures, I would strictly recommend that after this lecture, you watch the previous lectures. Yes, Kartika, good evening, Kartika. How are you? Kartika, good evening. So I also have a surprise for you that in the next class, most probably, or after that class, we will be solving the objective questions which have been asked in previous year examinations. So all the questions, अभी तक हमने जो भी पढ़ा है, starting from the highway, you can say highway development, starting from that chapter, we will be solving all the objective questions whichever have been asked in previous year SSC JE exam, and plus some questions from the ESC exam also we will be solving in the next class or next to next class. So that is the surprise for you, right? So now let us start with this topic. I am doing good, Kartika. I am doing good. I am also good. I am also good. I hope that you are fine and you are doing practice also. Okay. So let us start now. So what we are going to discuss in this chapter? So what we are going to discuss is that we are going to discuss about the highway materials. In the last class, we had started this chapter, the highway material, and in the last class, we discussed about the CBR, California Bearing Ratio. We also discussed about the plate bearing test. Plate bearing test. So these are the two tests that we have discussed in the previous classes. If you have not watched those classes, I would recommend that after this class, you go and watch that class. So now let us proceed. So now what we are going to discuss in this highway. So see, now we have started with the stone aggregates. Stone aggregates. Where are they used? When we are doing the construction of a road, where are they used? They sometimes may be used in base course, sometimes maybe they may be used in the sub-base course, sometimes they may be used in the surface course also, if it is a very small aggregates are there, right, which is also called as the bearing course also. So there also we use the stone aggregates. Now these stone aggregates have some properties. The first property is that it should have proper strength. It should have proper strength. This is the number one property of stone aggregate. But being an engineer, it should have proper. What is the meaning of proper? How much strength a particular, you can say, stone should have? That we will be discussing, right? There is a particular value for that. The next property is that it should be proper hard, or hardness should be there. Hardness. There is a difference between hardness and strength. For example, with how much load a particular member can be crushed, it is called as the strength of that material, and hardness is basically a surface property. Clear? So strength and hardness. Third one, it should have proper toughness. That is the number 3 property of the stone aggregates which can be used in pavement. It should be properly tough. Tough means how much impact load can it resist, or how much energy can it absorb per unit volume is called as the toughness. Number 4, and all these this parameter, hardness, toughness, I am on a strength also. I am taking the strength of material classes live on the textbook channel. Okay, you can also use my code, that is Varun K. You can use this code, you can get that package for you. Okay, and you will be further getting a discount of around 10%. So right now the structure analysis is going there. Okay, right now I am teaching structure analysis, and the strength of material I have already taught there, and in the evening the Mr. Deepak sir is teaching geotechnical engineering. So third one is the toughness. The fourth property is the durability. Now, what is the meaning of durability? That whether it can resist the environmental or weathering actions or not, or for how much time or for how many days is it properly in working condition. That is the meaning of durability, कि कितने दिनों तक वो चल सकता है. सिंपल सी बात है कि weathering action पे ज्यादा असर उस पे ना पड़े. That is called as the durability. So fifth one, the shape of aggregates. That is also we discuss. Shape of aggregates. Shape of aggregates, shape and sometimes size also. Size of the aggregates, right? Whether it is flaky in nature, whether it is an elongated aggregate, depending upon the shape of the aggregates, we also define that कि उसकी properties क्या हो सकती हैं. ठीक है. Number 6, the sixth property of aggregates is the adhesion with bitumen. Adhesion with bitumen. See, what is this bitumen? Regarding bitumen, I will be telling you later, but for the time being, just remember this thing, the black thing which you see, right? For example, if you are going on a road, you see that the road is blackish in nature. So that black thing is actually called as bitumen. Mostly we use bitumen, sometimes we use tar also, but mostly we use the bitumen. So bitumen acts as a binding material. It binds the aggregates, right? It doesn't take any load, it just binds the aggregate. For example, cement, in case of concrete, it just binds the aggregate. So cement acting as a binding agent. Cement also acts as a filler also. It fills the voids also, right? Okay. Similarly here in the highway materials, so what the bitumen does, bitumen acts as a binder. In highways, we have a filler material also. We have very small aggregates that act as a filler, that I will be telling you in the Marshall stability test. What is this Marshall stability test is, right? What is the meaning of flow value? Okay. What is the stability number? So all these things I will be telling you there. Yes. Now next property. So adhesion is there, shape of aggregates is there, durability is there, strength is there, hardness is there. So more than enough. So these are the 6 properties that we actually see in a particular aggregate. Now one by one we will be discussing that how these properties are actually measured in laboratories. One by one we will be seeing this thing. Let us go to the strength first of all. Strength. So strength is measured with the help of a test that is called as the crushing strength test or crushing test. Crushing, crushing test. The name of the test is very important, dear students. Name of the test has been asked many times in examinations, right? Okay. So you remember one thing, that the name of the test is very important. Okay. So the name of the test is very important. Okay, Vakul. I know Vakul. Okay. Okay, how did you come here, Vakul? Okay, so the name of the test is very important, right? So as far as the SSC JE exam is concerned, so the name of the test is very important. So now crushing, now see this word crushing. So the aggregates have to be crushed, right? So the aggregates have to be crushed. It means that slowly we have to increase the load on the aggregates. How this crushing test is performed? So we have a specimen, cylindrical specimen is there, right? So a cylindrical specimen is there. Yeah. The diameter of this cylindrical specimen, the height of this cylindrical specimen is nearly 13 to 14 centimeter is the height of this cylindrical specimen. Right, 32. Let me rub this. Let me draw it more clearly, so that will be much fine, right? Let me rub this. This is fine. Yeah. So let me do it like this. Yeah. So 13 to 14 centimeter is the height of the cylindrical specimen. The diameter of the cylindrical specimen is nearly 15.2 centimeter. That is the diameter of the cylindrical specimen. In this cylindrical specimen, I fill the aggregates. अब क्या करेंगे, सिलेंड्रिकल स्पेसिमेन में एग्रीगेट्स को भर देंगे। अब लेकिन क्वेश्चन ये आता है, which aggregates do I have to fill? Because if you have read about the geotechnical engineering, you must be knowing that we have different gradation of aggregates, right? So for more than 75 micron, we have the coarse aggregates. More than 4.75 mm, we have the gravel. More than 80 mm, we have the boulders, right? Okay, cobbles, boulders, etc., etc. The question is which aggregates to be filled. And as far as the SSC JE point of view is concerned, dear students, this question is very important, which I am telling you right now, right? So the aggregates which have to be filled here in this specimen, the aggregates which you will fill is, they should dry aggregates passing passing 12.5 mm sieve, 12.5 mm sieve, and retained on 10 mm sieve, 10 mm sieve. So again, dear students, I am telling you, this is very, very, very important. So the dry aggregates which are passing 12.5 mm sieve and which are retained on 10 mm sieve, only those aggregates are actually filled here. And we have the lid here, that is the lid, and with the help of a plunger, we slowly, gradually we apply this load. Now to go to this word gradually, this load is applied gradually. If you applied load instantaneously, or if it is an impact load, that test will be called as a toughness test. It will not be called as a strength test. In a strength test, the load is always and always applied gradually. Remember this thing. Is it fine till now? Is it fine till now? Is it fine till now? So the load is applied gradually. Now the question is, sir, what is this gradually meaning? What is the meaning of this gradual? So because in engineering, we cannot say more or we cannot say less. There has to be some specific value for that. So gradually here means it is 40 tons, 4 tons. 40 is the maximum value. That is 4 tons. Let me rub this. Yeah, correct. That is 4 tons per minute. Up to a maximum of 40 tons. 40 tons. So we have to apply this load gradually at the rate of 4 tons per minute. Okay, Mukesh is saying yes. Is it fine till now? Because these values which I am telling you right now, these values are very important, dear students, right? Whatever I am telling you right now, right? That is, whether it is the grading of the aggregates or whether it is the rate of the loading also is there, right? So whatever I am telling you right now, it is very important for SSC JE point of view as well as some state level PSC exams. This is very important, whatever I am telling you right now. Because in these exams, very small things are actually asked, right? And generally students, what they do is that they skip the small things. So small things make a big difference in when the scorecard is coming. Okay, Karthika is saying fine. Okay, so this is fine, right? Now let me ask you one question. In strength of materials, if you know, in strength of materials, for example, we know that stress is given by load per unit area, that is the stress. But this stress is actually calculated for gradual loading, right? Let us say this is the material and in the UTM you apply some load, universal testing machine, you apply some axial tensile load of P, and let us say A is the area of cross section. So the engineering stress is given by P by A. So we apply this load gradually. We also have certain loading for that, but that is not the case right now. We apply this load gradually. My question is, what will happen to the stress if you apply this load instantaneously? If you suddenly apply this load, dear students, what will happen? Can anyone tell me that? What will happen if you apply this load instantaneously? What will happen if you apply this load instantaneously? What do you say? Okay, Mukesh is saying no change, sir, I guess. Okay, Mukesh is saying no change, sir. Why there is no change, Mukesh? If you apply instantaneous load, will there be a change or not in the stress or not? What do you think? Kartika, what do you think? What will happen if you apply some load instantaneously? What will happen to the stress? Will it be same? Will it be different? If it will be different, then what will be the value? If the same load P is applied instantaneously. It will give less value of stress. Somebody saying it will give you less value of stress. Okay. What about others? What about others? Rahul is saying that it will give less value of stress. Okay. What about others? Okay. Mukesh is saying don't know. So Mukesh is saying don't know. I am watching your comments also on my phone. Okay. Don't know. What about others? Okay, now let me tell you what will happen. See, if you apply the stress instantaneously, the stress which is induced due to instantaneous or sudden loading, it is actually, dear students, 2 times the stress induced due to gradual loading. Remember this thing. We also have a proof of it. With the help of the strain energy, we can prove it, right? For example, now what is this strain energy? Half into stress into strain, or half into, or the area between the load versus deformation curve is said to be as the strain energy, right? Or the work done. So this is your load. This is the deflection which you are getting. The graph which you are getting is somewhat like this, a straight line. There is not a stress versus strain curve. A stress versus strain curve goes somewhat like this. It is not a stress versus strain curve. It is a load versus deflection curve, right? So the area under the load versus deflection curve, it is actually called as the strain energy, which is given by U. Clear? So this is the graph for a, you can say, gradual loading, and this is the graph for an instantaneous loading. This is the graph for an instantaneous loading, load versus deflection. So this is for impact load, or you can say sudden loading. We have the sudden loading. Actually, there is also a difference between impact and sudden, but for the timing, let us say both are same, right? Sudden loading, this is for gradual loading. And if you compare the strain energy, ultimately you will come out with this expression that sigma due to sudden loading is actually 2 times the sigma due to gradual loading, right? So it will not be small, it will be greater. Sudden is actually greater than sigma of gradually. And dear students, in ESE 20 also there was a question from this particular portion which I am telling you right now. In SSC JE 2017 or 18 there was a question from this topic. So again, it is very important. I have taught each and everything in the strength of material lectures which are available on the textbook site. So you can go to the textbook site, you can watch the demo lectures, you will have a lot of knowledge, right? Because I have started from the very zero topic, because very zero level I have started from the, you can say, engineering mechanics portion. Even if somebody does not know how to calculate the equilibrium reactions also, he will come out to know that how to calculate the equilibrium reactions, right? You go to the textbook site, you can watch those lectures, okay? And if you want to get that course, you can also apply this code, that is Varun K, and you will further be getting a discount of around 10%, okay? So this is what I was talking about. Now let us come to this topic, that is the strength test. So this loading rate is important, that is 4 tons per minute. This is important. Okay. Now what will happen once you apply this load? The aggregates will break. Even if the load is gradual, after some loading, right, the aggregates will break. After the aggregates will break, what we do is that after this, we again do the sieving of the aggregates. We again do the sieving. Now what is this sieving? Sieving means chhanna. For example, in the morning, you must be taking some tea, right? So before taking the tea, before putting the tea in cup, so we have this sieve with us. Okay, so we do the sieving of the tea so that the tea, you can say the tea, it is in that sieve and you get the liquid portion in the cup and then you drink that liquid portion. So that is your sieve, right? Similarly, we do the sieving here also. So after this, gradual loading is done up to what? Up to 40 tons. So you will slowly increase the loading by a rate of 44 tons per minute up to a maximum of 40 tons. And after that, you will do the sieving. Now the question is, in which sieve do we have to perform this test? So that sieve which we use after the test has been performed, the size of the sieve is actually 2.36 mm. This is important. This has already been asked in one of the examinations. So this sieve size is important. First was, before performing the test, it was 12.5 mm sieve and retained on 10 mm sieve. But now once the test has been performed, the sieve is 2.36 mm sieve. The particles passing 2.3 mm sieve are actually counted. Let us say that it is W2 gram. And let us say here initially the particles which we had taken, which are passing 12.5 mm and retained on 10 mm, let us say it was W1 gram. So from here, what do we calculate is that we calculate the aggregate crushing value. Aggregate crushing value, which is also called as ACV, aggregate crushing value. In percentage, we calculated in percentage. So it is actually given by W2 upon the initial W1 and multiplied by 100. That is the aggregate crushing value. You will be getting some value in percentage. This is also important. This formula is also important. Next one. Now the question is, sir, suppose I have got 20% value or 30% value or 40% value. What will it indicate? It simply indicates higher the value, poorer is the aggregate. Simple. जितना ज्यादा आपका वैल्यू होगा इसका एग्रीगेट क्रशिंग वैल्यू का, what does it mean? That a lot of aggregate has actually been broken down into smaller particles. It means that it is a very poor aggregate. Simple. If you use it in the on the surface course or even in the sub-base course also, what will happen if the heavy vehicles are coming? What will happen? The aggregates will break down. It will break down. It will create some voids. If voids are created, the pavement will settle down. Simple. And we will have potholes. You must have seen some potholes on the road, right? So one of the reasons is poor selection of aggregates. That is one of the reasons for potholes on road. Clear? Another reason is the poor drainage also, but that is also one of the reasons. Clear? So now the question is, sir, how much should be the value? So if you are using your aggregates in the base course, it is actually taken as maximum value is actually taken as 45%. So for base course, the aggregate crushing value should always be less than or equal to 45% for base course. Clear? For surface course, because on surface course we have heavy loads, right? For surface course, it should be smaller than or equal to 30%. It should be smaller than or equal to 30%. Clear? Now the question is, sir, you are saying that surface course, base course. What is the meaning of this surface course and base course? Let me tell you that. What is this surface course and base course? Let us say I am talking about a flexible pavement. What is this flexible pavement? Which is flexible in nature, which has grain to grain transfer of load. The pavement that we see, the road that we see in our day-to-day life, that is the blackish road, it is actually a flexible pavement. Now what is this base course? Let us say this is the compacted earth. We have done the compaction of this earth by calculating the CBR value, etc. We have done the compaction of this earth. On this earth, first of all, if it is a flexible pavement, first of all we lay a sub-base course. SBC, sub-base course. After this we have the base course. This is called as the base course. After this, what we have is the surface course. After this, we have the very thin surface course is also there, and above the surface course we have our vehicles. These are the vehicles that we have. So vehicles are actually running on the surface course. This is my surface course here. So flexible, this is the thing. What is for rigid? See, this base course and sub-base course, they have an advantage. I will tell you what is that advantage. Why do we use it? Why can't we use only base course? Why can't we use only sub-base course? So each and everything has a reason. In the design of pavements, I will be telling the reason also. The reason is actually thawing and you can say compression, thawing and you can say melting and thawing, right? Okay. So that is the reason. Freezing and thawing, that is the reason for that. In rigid pavement, what will happen is that this is the subgrade which has been compacted up to 95% of the gamma D max which is attained in the laboratories. Okay, so now we have this base course here. This is my base course. The sub-base course is absent in case of a rigid payment. The reason being, I will tell you the reason when I will be teaching you the design of payments. And then we have the cement concrete slab. Then here we have here the cement concrete slab which acts as a surface course. This is the cement concrete slab. It can be of PCC or it can be of RCC depending upon the loads which it has. RCC or PCC, whatever you want to provide. So that is what is happening in case of a rigid payment. I hope you have got it. Is it fine? Is it fine? Is it fine with you? Then I will proceed. Is it fine? Is it fine? Okay. Now, let me tell you one thing. Which is an important thing, by the way. Okay, fine. Now, let me tell you one thing, which is an important thing. The important thing is that, now here, let us come to this particular thing, right? So, the important thing is that this value, dear students, that is how much should be the base course, the aggregate crushing value for base course, how much should be the aggregate crushing value for the surface course. These 2 points are very, very important. I am again writing here. These are very, very important because after you can say, let us say 2 or 3 classes, I will be taking an MCQ also, which will cover all the MCQs, whatever have been asked from class number 1, right? That is the highway development. Right from that class, what are the different types of questions have been asked in various competitive exams? I will be coming with those questions and you will find that this question is repeated multiple number of times. In a lot of examinations, this question has been repeated. So again, I am saying that this value is very important. This value, the C value, as well as this thing, this C value, that is 12.5 mm and your 10 mm. Okay, so now let us proceed. Before proceeding, let me tell you one thing. So dear students, you can go with the Testbook Pass. Okay, so we have one pass. You will be getting an access to 100% courses plus 6,500 plus mock tests that we are providing. A lot of selections we have already made. A good exam strategy is also there, as well as you will be getting some expert guidance also.
One pass for 100 plus government exams जिसमें आपको मिलेंगे 100 से भी ज़्यादा courses, 3500 plus mock tests, 500 से भी ज़्यादा PDF study notes आपको मिलेगा सिर्फ 149 रुपीस में.
Okay. Next one. So, now next test is for the determination of hardness. So, hardness, dear student, is a surface property. It is not related with strength at all. It is just a surface property. Surface property. Okay, it is a surface property. Now the question is, why do we first of all calculate hardness? Now see, I was giving you the example of this pavement, right? Let us say that the vehicle is traveling with a speed of, let us say 80 kilometers per hour, 80 kmph. Okay, and this vehicle has some load or weight. It has some weight, let us say 1 ton or 2 ton, whatever it is. So due to this speed and due to this weight, that surface course particles, they will have, you can say, a surface contact with the vehicle, right? They will have a surface contact with the vehicle. You can say they will feel an abrasive force. Now, what is this abrasive force? When two different particles are, you can say, colliding with each other, the surface gets some force which is called as the abrasive force. Okay, so what will happen that the surface of the particle should be very, you can say, tough, very hard. The surface should be very hard such that there is no much loss of the particles. Simple. Okay, for example, let us say this is a bottle, right? This is a steel bottle. For example, I am taking an example. This is a steel bottle. If with my fingers, with my nails, I try to do something, will it get scratch on it? It will not get any scratch on it. But let us say that I have something else. Let us say I have a sponge. I have a sponge, and with my nails, if I try to do this thing, then it will have some scratches. The same happened with the Gorilla Glass. You must have heard about the Gorilla Glass that we use as a, you can say, tempered glass. Clear? Which we use in our mobile phones, Gorilla Glass. If you apply some nails on the Gorilla Glass, it will not have any scratches. But if it is an ordinary glass and you try to do something with the nails, then you will have permanent marks on it, permanent scratches on it. So that property which resists any permanent scratches is actually called as hardness. Have you got it? That what is the meaning of hardness? Then I will further explain you what is the experiment. Have you got it? That what is this? What is the meaning of hardness? Is it fine? Is it fine? The hardness meaning? Okay, yes sir, must. So Mukesh is saying must. Okay, Mukesh must रहना एकदम, ठीक है ना, अच्छे से पढ़ाई करना एकदम मस्त रहना. Okay, Kartika is saying yes. Okay, so now let us proceed further. Now how to calculate this hardness? To calculate the hardness, we have three tests, and the name of these three tests is very important. The first test is called as the Los Angeles Angeles aberration test. Aberration test. The second test is called as Deval aberration test or Deval aberration test. Deval aberration test. The third test is called as a Dory. Third test is called as a Dory aberration test. Now, before proceeding to these tests, I would like to ask you a very important thing. Can anybody tell me the difference between abrasion and attrition? Can anybody tell me that the difference between abrasion and attrition? I am waiting for your answers. Can anybody tell me that what is the difference between abrasion and attrition? Kartika, can you tell me the difference between abrasion and attrition? I'm still waiting for the answers. Can anybody tell me that the difference between abrasion and attrition? Because that is the important thing which I am asking to you. Okay, I am not getting any answer from you. Okay, now let me tell you what is the difference between abrasion and attrition. Now see, when two different particles, right, they strike the surface of other particle, right, another particle of different nature, that is actually called as abrasion. For example, we have a steel ball. If a steel ball it gets collided with stone aggregates, then that impact is actually said to be as abrasion. Now, what is attrition? If the same particles they collide with each other, okay, and they collide with each other, they do something to the surface, that is called as attrition. So attrition is in between the same particles or same material. That is between the same material, and this is between the different materials. Different materials. So that is what abrasion is, and that is what attrition. For example, stone to stone, that is attrition. Stone to stone. Stone to stone, that is attrition. And what is abrasion? Stone to steel, simple. That is what? Stone to steel. That is what attrition is. Attrition is a fast process. Abrasion is a slow process. No, that is not the correct definition of abrasion and attrition. Just remember one thing, abrasion is between different particles or different materials, and aberration is between the same material. Attrition is between the same materials. So now next thing, how do we do the hardness test? Let us first of all understand the Los Angeles aberration test. As from the name it is clear, the test was developed by Highway Board of Los Angeles in Los Angeles. Okay, that is in America. Now what we do is that again the same thing, we choose aggregates passing 12.5 mm sieve and retained on 10 mm sieve. Right, we do the same thing. The first step is same, whatever we have done here. So passed on 12.5 mm, retained on 10 mm sieve. We choose the same aggregates. Then we have an abrasion machine we have, right? What is the abrasion machine? That is called as the Los Angeles machine. Okay, it is a hollow cylinder. A hollow cylinder is there. A hollow cylinder is there. Right, a hollow cylinder is there, and the diameter, inside diameter of this cylinder, let us say this is a hollow cylinder, right? This is a hollow cylinder. The inside diameter of this hollow cylinder, this is a hollow cylinder. The inside diameter of this hollow cylinder is how much? It is important, has been asked in one of the examinations. It is nearly 70 centimeter. 70 centimeter is the inside diameter, and the length of this hollow cylinder is nearly 50 centimeter. That is 50 centimeter. Remember these two, you can say dimensions very carefully. That is 70 centimeter and your 50 centimeter, right? 70 centimeter and the 50 centimeter. Now what we do is that we put the aggregates in it. These aggregates which are passing 12.5 mm, retained on 10 mm sieve, we put these aggregates inside this particular machine which is called as the Los Angeles abrasion machine. Okay, we put it inside it. Along with it, because it is an abrasion, right? It is an abrasion, we cannot just put aggregates, we have to put some other material also. So what we do is that we put some steel balls also. We put some steel balls also. Steel balls whose weight is nearly 390 to 440 grams. In between these, that should be the weight of the steel balls. We put the steel balls. We have a number of steel balls. As far as the IS code is concerned, IS code says that you put 6 steel balls. You put 6 steel balls and the collective weight should be 390 to 445 grams, right? Sorry, not collective. A single steel ball has a weight of 390 to 445 grams. Okay. Now, what is the diameter of the steel ball? The steel ball that we use, its diameter is generally 4.8 centimeters, the diameter of the steel ball. We put these steel balls inside this cylinder along with the aggregates, and this cylinder is actually rotated. This cylinder is actually rotated, okay, and the number of revolutions, N, is the number of revolution. It is 500 to 1000. 500 to 1000. Depending upon the type of aggregate that we are using, but generally it is in between 500 to 1000. That is the total number of revolutions we are giving, and N, which is in RPM, it is 30 to 33 RPM. 30 to 33 revolutions per minute we are providing, and the total revolution is actually between 500 to 1000, the total number of revolutions. Now, if the cylinder is rotating, it has the steel balls also, it has the aggregates also. What will happen? The steel balls will get collided with the aggregates, and what will happen? The surface of the aggregates will get abrasion, will feel abrasion. So some particles will be lost, and then hence we calculate the abrasion value. Abrasion value. How do we calculate the abrasion value? Again, we do the same thing. Again, we take out all the aggregates after 500 to 1000 revolutions, depending upon the type of aggregates. We take out the aggregates. Again, we do the sieving of the aggregates. Again, we do the sieving. But now, this time, in the case of the hardness test, the sieve that we use, it is not 2.36, it is 1.7 mm sieve. This question is a very confusing question, dear students, that for abrasion value calculation, we use the sieve of 1.7 mm, but for the crushing strength test, what we had is a 2.36 mm. Here we had this 2.36 mm, but here we have it is 1.7 mm sieve we use, and some particles will be passing. Let us say that the weight of those particles is W2 and W1. Let us say initially we put inside it was W1, Okay, then we calculate the abrasion value. Abrasion value is given by, in percentage, it is given by 100 times of W2 upon W1. The formula is same, it is not going to change. So hence we get the abrasion value. That is how we get the abrasion value. Rahul Bhardwaj, 1.7. Yes, very good Rahul. It is 1.7 mm. Yes, correct. Again, I am telling you it is a very confusing thing, but we have to remember this. Abrasion 1.7. Abrasion 1.7, right? So see, this is N here. This is N here, right? Okay. And here also 7. S-E-V-E-N, and abrasion. A-B-R-A-S-I-O-N. You can remember it like this. Abrasion N, 7. So it should be 1.7. You can remember it like this. Okay. Now the question is, how much should be the value of this abrasion value? If the pavement is a high class pavement, means a very good quality of pavement, your abrasion value should always be less than or equal to 30%. So 30% is the maximum value which is allowed. So maximum is 30%, right? But sometimes we can also go up to 50%, sometimes. Okay. Now in which case can we go up to, you can say 50%, if it is a water-bound macadam. What is this water-bound macadam? Go to my class number 1, the development of highways. In development of highways, I have very well explained in very much detail what is the meaning of water-bound macadam. Water-bound macadam क्या होता है? जब हम स्टार्टिंग में जब रोड बनाते हैं तो आपने देखा हम लोग क्या करते हैं, पहले एकदम रोड को साफ करेंगे, फिर गिट्टियां कूटते हैं, उसके ऊपर रोलर चलता है, बिटुमिन के डलने से पहले रोलर चलेगा, फिर पानी डाल देता ताकि धूल ना उड़े, पानी डाल देते हैं। तो वो जो सड़क उस टाइम पे बनती है, उबड़ खाबड़ सड़क होती है, लेकिन गाड़ी चल सकती है उसके ऊपर, उबड़ खाबड़ सड़क होती है, राइट? That is called as the water-bound macadam. You go to my class number 1, you will find it, the meaning of water-bound macadam. And I have also shown a picture also in the first class, right? That is the water-bound macadam. Clear? Next one, the next test that we use here is called as the Devil aberration test. That is a Devil aberration test. That is also similar, but here we have two cylinders. Let us say this is one support here, right? One cylinder will be somewhat like this. Here we will have one cylinder, and again this cylinder will be attached with another cylinder. Here also we will have one cylinder. So we have two cylinders here, and here also we will have a support. Otherwise the function of this test is also similar. So what this test, Los Angeles test, was doing, we have the similar. They are also rotating with some number of revolutions. Total number of revolutions are there, right? Some RPM is also there. Again the same thing that we are doing, and the angle, this angle at which this angle, these you can see with the horizontal, it is generally 30 degree. This angle is generally 30 degree with the horizontal. It is generally 30 degree with the horizontal. So we have two hollow cylinders. The hollow cylinders are moving with some, you can say with some revolutions per minute they are moving. And here also we do the same thing. We put the aggregates also, right? We put the aggregates, and some steel charge is also put. Generally 6 number of steel balls. 6 numbers. I guess as far as I remember, this question has been asked in some of the examination. How many steel balls do we use? So it is 6 number, right? 6 number of steel balls which are of spherical shape, they are actually used, and the diameter of the steel ball is 4.8 centimeter is the diameter. The only difference is that here the total number of revolutions that we are taking is 10,000. 10,000 is the total number of revolutions that we are taking in this case. That is my 10,000. Okay, so 10,000 is the total number of revolutions that we are taking. Clear? It is fine. Is it fine? Similarly, we have the dory also. So we have different dimensions, but the function is same. Similarly, we have the dory also. Again, it has, you can say it rotates at a speed of 20 to 30 RPM, 28 to 30 RPM it rotates. 28 to 30 RPM. It also has certain number of revolutions. Again, here also we put some charge also. That is called as charge. This is steel balls. These are called as charge. C-H-A-R-G-E. That is called as charge. Here also we are doing the same thing. So the concept is same. That is abrasion is the concept. Okay. So now next thing, the next value, the next property that we are going to discuss, number C, is the toughness. Toughness. That is my toughness. Okay, now what is the meaning of this toughness? Toughness basically means how much energy can a particular material or a particular particle can absorb per unit volume without getting crushed or without breaking, simply. For example, in strength of material, if you remember, so this is my steel rod or steel bar, whatever it is. If you are applying some load P here and P here, so before breaking, how much maximum energy this particular bar has absorbed? Initially it is strain energy, then we have the resilience, proof resilience, okay, and then we have the toughness. So how much energy or how much impactive effort it can absorb without breaking is actually called as toughness. So similarly here also, the toughness test is also similar to crushing test, but in crushing test we were applying a gradual load, but in toughness what we will be doing is that we will be applying an impact load or sudden load. Impact load will be applying. That is the only difference between the toughness test and the crushing test. Clear? So without fracturing, how much load it can, how much energy or how much load, how much impact load can it resist without fracture, it is called as the toughness. Now here what we are doing is that we are taking a cylindrical steel cup. Again we are taking a cylindrical steel cup whose diameter is 10.2 centimeters, the diameter of the steel cup, and the depth is nearly 5 centimeter is the depth. Clear? And we have a hammer. We have a big hammer. So big hammer is there like this. A big hammer is there. The weight of the hammer is important, dear students. The weight of the hammer is generally in between 13.5 to 14 kilograms. That is the weight of the hammer. In geotechnical engineering, when we do the compaction, there we have a rammer, right? There we have a rammer. The weight of that rammer is also important, and the weight of this hammer is also important. Remember this, right? It is in between 13.5 to 14 grams. Next thing, this hammer is basically dropped. This hammer is dropped in this mold from a certain height, and the height is actually, it is also very important, it is 38 centimeter. So from 38 centimeter height, this much of load is actually dropped in this cylindrical specimen whose diameter was 10.2 centimeter, and it had aggregates. It had aggregates. Now how many blows are given? 15 number of blows are given. 15 number of blows are given. This is important. So we provide a 15 number of blows. 15 number of blows are given to the aggregate. This is also important. What is important? Weight 13.5 to 14. Number 2, height 38 centimeter. Number 3, number of blows. 15 number of blows we provide. Clear? So we provide a blows of 15 number. 15 number of blows are provided. Now the aggregates which are used here, again the same thing. That is passing 12.5 mm and retained on 10 mm. So again the same aggregates we are using. Passing 12.5 mm and retained on 10 mm, we are using the same aggregates. We provide 15 number of blows. What will happen if you are providing the blows? Some aggregates will get failed or will get crushed. Not getting crushed, the correct word is fracture. Thus some aggregates will get fractured. They will be converted into powdered form, and after that, after this 15 number of blows, we are doing the same thing. That is, we will be passing the aggregates. Now we will be passing the aggregates from again 2.36 mm sieve. We will be passing the aggregates and we will be calculating what? Our impact value. Impact value. And impact value is what? Impact value is given by, again the same thing, 100 times of W2 divided by W1. You will get the impact value. Normally, the impact value should always be less than or equal to 30%. The impact value should always be less than or equal to 30% in the wearing course. Wearing course means the top courses, right? Wearing course. That should always be less than or equal to 30%, right? Maximum permissible value is 35. Maximum permissible value is 35%. So it should be, in any case, it should be less than 35%, but generally it should be less than 30%. The maximum permissible value is 35% for, again the same thing, bitumen macadam. Not water-bound macadam, but bitumen macadam. And for water-bound macadam, which is considered to be one of the poorest roads, that is nearly 40%. We can also extend this value. It can go up to 40% for water-bound macadam. So these are the various values of impact, or you can also say it is the impact values. Again here we have 2.36 mm, not 1.7. So initially in the crushing also we had 2.36, and here also we have 2.36, but in the hardness we had 1.7. Clear? Is it fine? Shall we proceed now? Shall we proceed? What is the time? Okay. Shall we proceed? You say, shall we proceed? आगे बढ़े हम लोग, आगे बढ़े. I want a confirmation from everyone. Is it fine till now? अभी तक okay है ना? Okay, Mukesh is saying yes. What about others? Okay, yes sir, proceed. Kartika, are you with us? Or are you gone? Are you still watching, Kartika? Okay, now let us proceed further. Now next, number D. Now what we are going to discuss is that after this test, that is the impact test, the next test that we are going to do is the soundness test. Soundness test. Now what is this soundness? Soundness basically tells you about the durability. If you go to, you can say if you go to concrete section, if you go to the concrete section, their soundness has a little bit of different meaning. Their soundness basically tells you, for example, we have the Lee-Challier apparatus, right? Or we also call it as Lee-Chatter's apparatus, right? Okay, but that correct name is Lee-Challier. So we have the Lee-Challier apparatus. Autoclave test is there, or Lee-Challier test is also there. So Lee-Challier apparatus basically tells you about the soundness, and there soundness basically means how much volume change is there, simply. But here the exact meaning of soundness in case of aggregates means how much is the effect of weathering action. Weathering action, what is the meaning of weathering action? See, sometimes we have rain, sometimes some chemical changes are there in the soil, sometimes because there can be some acid rain also. Due to pollution, there can be some acid rain. Now, due to those things, whether there is deterioration of my aggregates or not, that is what we are going to check ultimately in this section. That is what we are going to check ultimately in this section, that how much is the effect of weathering action. So we are going to see the weathering action. Weathering action. That is what we are going to see. Clear? Now, how to see the weathering action? So remember this chemical name. This chemical name has been asked many times. This is called as sodium sulfate. Sodium sulfate. And we have one more chemical that has also been asked in exam, that is called as the magnesium sulfate. Magnesium sulfate. So we have two chemicals. First one is the sodium sulfate and another one is the magnesium sulfate. So what do we do is that we dip our aggregates in either of the two. Either it is sodium sulfate or either it is magnesium sulfate. We dip our aggregates for 16 to 18 hours. For 16 to 18 hours. After that, what we do is that after dipping them, or you can say soaking them in these solutions for 16 to 18 hours, then we take out the aggregates and then we do the oven drying. Oven drying, and the temperature of oven drying which is done, it is in between 105 to to 110 degrees Celsius. Now, dear students, I am writing a lot of values here, 2.36, 1.7. It seems to be a little bit complicated, but if you revise it 2 or 3 times, it will be very much easier for you. Again, I'm telling you, right? So, we do an oven drying. The temperature of oven drying is in between 105 to 110 degrees Celsius is the temperature in oven drying. After that, what we do is that again we do the same thing. Again we put it in the sodium sulfate solution, again oven drying, again sodium sulfate solution, again oven drying, right? And this particular procedure is called as a cycle, one cycle. This is actually called as one cycle, right? Immersion drying, one cycle, immersion drying, one cycle, immersion drying, one cycle. So this is actually called as a cycle. Okay, now how many cycles do we perform? So if we are using, you can say, if we are using, let me tell you, if we are using the sodium sulfate Na2SO4, if we are using Na2SO4, the number of cycles that we generally proceed, it is in between 10 to 15, but generally 10 cycles for sodium sulfate. Just write 10 cycles for sodium sulfate. And for magnesium sulfate, the cycles are also taken as 10. So we have nearly 10 cycles. So now nearly 10 cycles we are taking, and after that what we'll be doing is that we will be, after 10 cycles for both, we will be doing the sieve analysis again. Sieve analysis. Again do the sieve analysis. Now for sodium sulfate, after 10 cycles, the percentage loss, because the chemical change is there, right? It will have some percentage loss. The percentage loss should not be greater than 12% for magnesium sulfate. Very, very, very important. This what I have written here. Very, very, very important. And for magnesium sulfate, the percentage loss, it should not be greater than 18%. It should not be greater than 18%. Again, I'm telling you, this is very, very, very important. Okay, so there will be disintegration of the grains, right? And for the sodium sulfate, it should not be greater than 12%. And for the magnesium sulfate, it should not be greater than 18%. The percentage loss should not be greater than this. Okay, this is called as a wet and dry cycle. This cycle is also called as a wet and dry cycle. Wet and dry cycle. CYCLE. Wet and dry cycle. Okay. So that is what we do in the soundness test. So with the help of this test, we will be able to analyze whether a particular aggregate will have, you can say, very poor results in the case of a weather is changing abruptly or not. So that is what we, you can say, calculate with the help of this particular method, which is called as the soundness test. After this, we have the shape test. Shape, one we have the flaky shape and one we have the elongated shape, right? फ्लेकी एंड एलोंगेटेड. फ्लेकी को हिंदी में आप बोल सकते हो चपटा, और एलोंगेटेड को बोल सकते हो लंबा. राइट, चपटा और लंबा, एक की थिकनेस कम होती है, एक की लेंथ बहुत ज्यादा होती है. फ्लेकीनेस और एलोंगेशन टेस्ट. But dear students, it's almost time. Let me see the time also. The time is nearly 10:27. So dear students, it's almost the time. So now let us do one thing. Let us call it a day. Okay, let's meet tomorrow again with the highway material part number 3. We will be discussing in the next class the shape test. We have the angularity number also. We have the elongation test also. Okay, we have the flakiness index test also, specific gravity determination test also, and adhesion with bitumen test also. So these tests we'll be discussing in the next class. Till then, you take care, you keep practicing, okay, because only practice makes a man perfect. So you, even a woman also, okay, so just keep practicing. So tomorrow we will meet at the same channel. Like, share and subscribe. Also share with your friends. Whosoever is not able to, you can say, grasp the concepts from college or from some other places, he or she can learn, right? Because knowledge हमेशा बांटने से बढ़ती है. If you share, your knowledge will certainly increase. Okay, so you share with your friends, like, share and subscribe. Thank you everyone. Thank you. Have a nice day. Take care. Bye bye. Good night.